If we're having to use handwriting, we typically put an arrow over the variable. For example, u with an arrow. Example, consider the vector. So there's v with an arrow. 3, 4. Notice, those are not parentheses. They almost look like parentheses, right? But they're not. That's how you know it's a vector, is because of the little angled parenthesis looking thing. This is a directed line segment that extends from the origin to the point 3, 4. So if I go right 3 and I go up 4, this is the vector 3, 4. This version of a vector is called component form. 3 is the horizontal component, 4 is the vertical component, which again makes sense. Horizontal means I went right 3, vertical means I went up 4. Any questions about this component form of a vector? So that just works like everything else we've been doing, right? Not anything crazy. So moving to the next one, can you draw vector u, which should be at -5, 4 when in component form? Is everybody done?
But it's only one line. It's not like a triangle. It's just vector direction. It's just a straight line.
The vector is the hypotenuse, right? We can break it into its component forms with 2 legs, but the vector is the hypotenuse. If you want to think about it as right triangles. Questions on that one? Anybody? Next, write a vector in component form given the initial and terminal points. So here, it's not starting at the origin, right? That's my problem. So it tells me the vector starts at, so again, let me tell you this. Direction matters. So you see how this is vector AB? That's different than vector BA. This means I start at point A, I end at point B. Okay, so if point A is at -2, -4, this is point A. B is at 3, 1. Then vector AB would be from here to here. That is vector. Because the direction matters. Line, I mean, it is like a line, but lines could go in either way. It's the same thing, right? Magnitude and direction matter. So this is what it looks like. So I drew it in its original form and in its component form in standard position. So if I needed to make this into component form, guess what I need? I need to know how far did I go along the x-axis. So if I went from -2 to 3, guess what this value is? 5. Is everybody good where I came up with that? Just adding and subtracting. From -2 to 3 means I went right 5. And then if I was down at -4 and I went up to 1, guess what that value is? 5. So if I have to put it in component form in the standard position, it would be I went right 5, I went up 5. That would be its component form. So here's what you need to know about vectors. I don't know if they talk about this here. You guys know I don't read ahead. They may talk about it later. That vector and this vector are the same vector. They're the exact same. They've got different initial positions, right? They're starting in different places. But they go right 5, they go up 5. So they have the same magnitude. They have the same direction. They're the same vector. Their place in space does not matter. Okay, that's why I can move it to standard position. Standard position just means the starting point is the origin. That's all standard position is. Okay? And again, they may talk about that later. That was just me ad-libbing. Something I thought I needed to share. No. Look back on the previous page. Do you remember how we were drawing component form of vector? They're almost parentheses. Right? I didn't know what to call them. Pointy parentheses. Is that a good name for them? And I guess I should be good with my naming. Again, this is not stuff I'm good at. This should be vector AB is 5, 5. The naming convention. Great job. You see the note at the bottom? It says two vectors are equal if they share. What two things must they share? Magnitude and direction. I'm so good at this. The magnitude is just a fancy word for length. That's just another fancy word for distance. Right? We've been doing magnitude this whole time. The hypotenuse of a right triangle is the magnitude. Right? When you find that value. And you can see here, if I'm given a vector in the form xy, its magnitude is given by, it looks like the absolute value. Well, with a vector, that just means the magnitude of the vector is. Look at that formula. All the same, right? It's the distance of the hypotenuse of the right triangle. So here, what would be the magnitude of this one? 15, negative 15, and 20. Hopefully somebody knew it without having to do the math. Maybe not. It's 25. How could I know that if I didn't know that was a Pythagorean triple? That's a 15, 20, 25. Pythagorean triple, a form of a 3, 4, 5. Right? It's just a 3, 4, 5. But they've all been multiplied by 5. Thank you. That's all that is. Trey was flabbergasted that I knew that one. But that's just a 3, 4, 5. If I didn't know, it would be the square root of negative 15 squared plus 20 squared. Which I'm going to guess is the square root of 625. Just a guess. Because this is 400 and this is 225. And that would be 625. But I knew the square root of 625 was 25. But anyways. I didn't do all that in my head. I just knew 15, 20, 25, guys. It's just Pythagorean triple. Hey, what if it was 1824? 30. Huh? What if it was 3040? Okay. Oh, so close. You need to simplify it probably. 4 radical 2, because this is going to be what kind of right triangle? It's going to be an isosceles right triangle, because it's got the same x and y values. You follow? So if I know these, if it was 1 and 1, it's radical 2. Well, it's 4 and 4, which is. Yep.
So you got to learn how to break down radical 32 again.
Yep. So if I was stuck with radical 32, you download something on your calculator. We need to ask Owen. Did you not find that in all your searches?
I was looking for it. It's like square.
Okay. 16 times 2. Did Ethan get you? 32, we want to do a perfect square times any other integer. So that could be 16 times 2. The square root of 16 is 4. 2 stuck underneath the radical. Am I going too fast, or you guys know how to get that? I just did the Pythagorean theorem. Is everybody okay? I know I kind of am. This is called a unit vector. Well, where have we been dealing with unit something before?
Circle.
Unit circle. So what was the unit circle?
Circle the radius of 1.
Centered at the origin, radius of 1. A unit vector, guess what? Its magnitude is 1, which means its radius is 1. If it was a unit circle, move there to that spot. So how can I adjust any vector to have a magnitude of 1? Basically, I'm making it its unit vector. I'm going to find its actual magnitude. I find its actual magnitude. And then I'm going to divide the vector by that number. Right? It's almost the same thing that I showed you guys. You're not going to remember because it's the very first thing that we did in here. But if you remember when we did the unit circle, I told you technically this is 1. And so that means this would be radical 2 over 2, and this would be radical 2 over 2. But if I just doubled all of that, this would be radical 2, and 2. So this is the triangle I knew, even though really the hypotenuse is 1. I just basically took this triangle and divided it all by its magnitude. You see how this was the magnitude? I divide them all by. Okay, so anyways, that's what we got going on here. I'm basically taking my vector that has magnitude and direction. I am keeping the direction, but I am shrinking the magnitude to 1. Right? Or it could be scaling it up. Thank you, Ethan.
I got that right. But right when you said that, I said you just don't draw the line as long. Yeah, that's exactly what you do.
Well, you draw
I'm a
longer.
savant. I'm a savant.
I don't know what they drew here. You see where it says, here's what that looks like? Yeah, but I mean, I don't have it. I mean, I could pull it up. Right, so if this was my vector and I wanted to make it be a unit vector, I just have to keep the same direction. Find a unit vector that shares the same direction with the vector 6, 8. So here's the vector 6, 8. What's its magnitude?
10.
Thank you. It's a 6, 8, 10. It's a 3, 4, 5 Pythagorean triple. Doubled. Okay? So its magnitude was 10. And if I want to keep the same direction, let me use a different color. There it is. What would be the components of my green vector? Which would be 3/5 and 4/5. Because this would be a 3/5, 4/5, 5/5 Pythagorean triple. Which 5/5 is just 1. Oh, I need a magnitude of 1. Oh, okay. That's sweet. Okay. So you see how I just, okay, let me explain this for a second. Because I know when I first learned this, I forget. You guys are learners. Probably the first 2 times I learned this, I hated this, the way this looked, because it just confused the mess out of me. Until I just finally came to the realization it's all a right triangle. And I wish my teachers taught it a right triangle, which is why I'm teaching it like that. Right triangle, thank you. So here, this is just the magnitude of V. That's all that stands for. So 1 over the magnitude of V is me scaling this back. So I found the magnitude of V was 10. So I just did 1/10 times that vector. Right? That's all that means. So what's 1/10 times 6? 6/10. What's 1/10 times 8? 8/10. I mean, that's all that formula means. Again, it looks confusing because you got absolute values, but absolute values are just magnitude. It's just the distance from 0.
SUV.
So here, vectors can be written as a linear combination of I and j. I and j are known as the standard unit vectors. I represents the x-axis, while j represents the y-axis. Any vector in component form can be written as a linear combination of I and j. So when I look at this vector has component form of 3, 4. What does this mean? Like, explain to me, how could I draw a vector with component form of 3, 4? I know it went right 3, it went up. So if I want to write that in its linear combination, I would write 3I plus 4J. And my teacher that worked for NASA, he uses I hat and J hat, and so I just started doing that because he was smart. So he was really old. That's maybe an old, outdated system, but that's the way I write mine. So yeah. So now then, because we're dealing with an XY coordinate plane and we wanted to go to polar, we have all the same relations that we had before. So there's the 4R. Example, Noah pulls with a force of 75 pounds on a wagon handle at an angle of 30 degrees above the horizontal. This is physics. Welcome back to physics, okay? Love this. This is wonderful. So here is the box that Noah's pulling, or it's a wagon handle. Who cares? Okay, here's the wagon. Here's the handle. What force does he pull on this handle with? That means that its magnitude is 75. The magnitude of the vector is 75. But he's not pulling with 75 pounds in one direction because he's pulling up some as well, right? It's 75 pounds in total. You can see here, let me use a different color. It tells me that this is with an angle of 30 degrees above the horizontal. So this is horizontal. He's pulling 30 degrees above that. Resolve this force vector into its vertical and horizontal components. So what I want to do is, I want to find the I and the J. So I can write this with I hat and J hat. Well, guess what the I value is? It's this side length. Can you guys tell what's going on with my drawing? I don't like the green so much. Is everybody okay? That says 30. Y'all see that? Okay. Y'all get better eyes than me. I'm getting old. So this component here, again, you got all these dang formulas. Let's do it the formula way. This is the X component. So guess what I could do? I could just say, well, what is the radius or the magnitude? 75. And it's going to be cosine of the angle, 30. What's cosine of 30? Radical 3 over 2. So that means this is 75 radical 3 over 2. Using the formula. That's not the way I would do this problem. Okay, but I figured that's the way most of y'all would do it. Anybody guess how I could do it? This is adjacent to 30. And I know the hypotenuse. Which trig function deals with adjacent and hypotenuse? Cosine. So I could say cosine of the angle equals the adjacent. That's what I'm looking for over the hypotenuse. Well, so you can see here, if I set that up, 75 cosine 30 is exactly what I had to start with, right? I would just do it from a triangle perspective instead of memorizing a formula. But it all works the same. So, just like I told you guys, do unit circles. Anyways, have you guys found the other component? What is it? Thank you. Do I need to go over how to do that one? Is everybody okay? So now then, to write it in its vector form, I would write 75 radical 3 over 2 I hat plus 75 over 2 J hat. Or you could write it like, depending, I don't know how they want this, 75 radical 3 over 2, comma, 75 over 2 with those pointy parentheses. Right? Those mean the same thing. One of them just has I and J, one is in. Questions? Am I done with that page? Yes. Page. Does this one say an airplane's westward velocity? Okay. I was afraid I got my pages out of order. An airplane's westward velocity. Guess what matters about it being westward? Direction, because these take magnitude and direction. So its westward velocity is 200 miles per hour. So the airplane's going west at 200 miles an hour. It's going northward at 150 miles per hour. So what's the actual speed of the airplane? Yeah, r equals the square root of x squared plus y squared. Or I did them backwards. Whatever, it doesn't matter. Right? I'm just finding the magnitude of that vector. This is a 3, 4, 5. Again, 150, 200, 250. It's amazing if you guys will learn those, how quickly you can just not have to plug in the Pythagorean theorem. But it's okay. You're calculator guys. Thanks. Find the direction angle of its flight. So I'm looking for, again, a good question. I don't know what it's going to ask for. I could find this angle by doing inverse tangent of 150 over 200. But I don't know if it wants this angle or if it's going to want me to rotate. I want to assume it's going to want me to rotate from here. Or who knows? It could be like the dang pirates and it could treat this as 0. I don't know. I've never done any. We'll just see when we get to those problems. All right, but finding the angle is the same process. Find the value of A in the vector. So now I've got a vector. I don't know A. I know B is 24. And I know its magnitude is 25. This is just another fancy way to write magnitude. I don't know why they've got 2 lines, sometimes 1 line, sometimes. All means the same thing for magnitude. So, how could I figure this out? Pythagorean theorem, right? I'm going to do this one like I don't know the triple. So I could say 25 squared equals the square root of a squared plus 24 squared. So this would be 625 equals the square root of a squared plus, I don't know what 24 squared is. I'm going to need some help there. 596. 576. Okay? So now then, I'm trying to solve for A, right? If you guys don't know how to do this, I'd have to solve for A. So A is being square rooted, so I square both sides. So I'm going to have something ugly. I'm just going to leave it for a second. 625 squared equals A squared plus 576. I'm doing something wrong. Yeah, I'm an idiot. Okay. That's what I get for trying to do it this way. Look, this shouldn't be squared. I'm sorry. I combined 2 formulas. I was doing the Pythagorean theorem. Okay, here's your formula. R equals the square root of x squared plus y squared. Is everybody okay with that? That's my formula. And now that I know R is 25, and I did 24 squared was 576. Now, I've got to, so the stuff I was telling you is true. Now I got to get A by itself, so square both sides. So 25 squared is 625 equals the square root of A squared plus 576. But I'm an idiot, and that shouldn't be under a square root anymore. My brain is not working. Right, so that's why I squared it, was to get rid of the square root, you doofus. I'm talking to myself. I'm not calling anybody a doofus. All right, anyways, subtract 576. I'm going to guess that's 49. Just a hunch. So A equals 7. Because this is a 7, 24, 25 Pythagorean triple. All right, that's the last one I have memorized. So here's the deal. Here's the formula. The dot product of 2 vectors. So if I have 2 vectors, A and B, C and D. You see how they're in different forms. I can find the dot product by multiplying the x components by each other. A times C. Multiplying the y components by each other. B times D. Add them together. AC plus BD. Notice, dot product is not a vector. It is a scalar. It's just a number. Another name for a dot product is a scalar product. So let's do an example here. If they're making this big deal about it, why do you think they're making such a big deal? Because people mess this up all the time. Right? So look, if I multiply v dot u, I just multiply the x components. What's 2 times 4? 8. I multiply the y components. What's 3 times negative 6? Negative 18. To get the dot product, you simplify this. What is 8 minus 18? That's it. That's the dot product. Dot product is a scalar. It's no longer a vector. Okay? So negative 10 is the dot product. It is not 8i minus 18j. Don't do that. Okay? Dot product is a scalar, not a vector. Questions there? Other flavor of a dot product. We know the magnitudes of the vectors and the angle between the vectors. So if we knew the component form, it's as easy as doing what we just did. Right? If you know the components, the x and y, the x and y. But if we don't know the components, we can find the dot product using the magnitudes and the angle between them. It's another way to do what we just did when I know different things. So here, what's the magnitude of v? It's 4. What's the magnitude of u? It's 7. Cosine, what's the angle between them? And I would plug that right in my calculator. 7 times 4 is 28. Cosine of 54 is, I don't know. Anybody get this number?
16 plus 4, 5.
Good enough for me. And it's a dot product, right? So it's no longer a scalar. It's just a number answer. I want to do a dot product. Questions there? I don't think you're going to have many questions like that because that looks like that's just an afterthought. Like they've thrown it in. Here's another way to do dot product. Right? But when I learned dot product, this is the way they taught me first. Which is, so if vector u is xy, vector v is ab, then we could add or subtract the vectors. If I added the vectors, guess what? You add the x components, you add the y components. What else do you want from me? So let me show you algebraically how to do it. If I added the x components, I would get 6. If I added the y components, I would get amazing. Okay? Is okay with that? Now, graphically, here's what that looks like. So this is 3. So if I drew vector 2, 3. This is vector 2, 3. Is everybody okay with that? If I wanted to add vector 4, negative 1 to that, I'm going to put the butt of this vector at the tail. I did it backwards. This is the beginning, this is the end. Let's go this way. Beginning and end. I'm going to put the beginning of this vector at the end of vector 2, 3. And then I'm going to go from there at 4, negative 1. Which means from here, I could go right 4 and down 1. Everybody see how I got there? Right 4, down 1. And so then what is my component, or what's my new sum? I went right 6, I went up 2. See that graphically, how you can do that? Questions there? So again, algebraically, what's different when there's a subtraction? Any guesses what you're going to have to do? Distribute that negative. So now I'm going to be at negative 2, 4. Okay, so graphically, if I did that one, 2, 3 is still in the same spot. Now, where was 4, negative 1? So 4, negative 1, let me do it this way, see if it'll work. Give me just a second. Let's see if I can do this. So 4, negative 1 is there normally, right? It's normal component form. Because it's subtracted, because it's being subtracted, that means it's going the opposite direction from where it normally is. 180 degrees in the other direction. So this vector then would be here. Is that, that's not 1. Sorry, let me get it lined up. Is that 2 or is that 4? That's 2, ain't it? That's close enough, right? Oh gosh. 4, 1. Then I would take that reverse director vector and put it there. Am I at -2, 4? Right? You see how I'm close enough? So we're okay with that? Opposite direction. So subtraction, the normal vector goes here, but because I'm subtracting, it goes the exact opposite direction. I'll finish this, baseball guys, tomorrow sometime. Probably in this class. I'll post it ASAP. Was that the end of that page? Yes. Oh my gosh, I got that many pages to go? These are the fun ones at the end. No, I need to look up the due date. I still haven't done that. I won't be here Friday. Thursday, if you're going to do it in class, or, yeah, because it's got to be in class. It's the AP one.
I'll get here early after I leave college.
Anytime, it's fine.
Is Mr. Kent good?
Yeah.
Yep.
See the Cal 1 teacher?
Yeah, that's who they put down with.
Yes. He's the one that taught me.
Head triangle guy.
I don't know, he's gotten soft.
Got soft.
He's the one, like the way that I do the unit circle is the way he taught me to do the unit circle. And now he makes them memorize it at Northeast. So I'm wondering if he's gotten soft. He doesn't tell them K-Todd stands for know these or die. I mean, he's getting politically correct. I don't know, sometimes. He lives two houses down from me though, so I'll set him straight if you need anything. I should say, oh yeah, his son made a 36 on the ACT, so I think he'd be all right. Oh, not this again. Oh gosh. This is. I tried to teach this for the first time. I didn't do a very good job 5th period, so I'm probably not gonna do a very good job here. I'm gonna tell Beniac to shut up. This is just gonna be wonderful. What a life. Okay, Ellis, not too late. So now a scalar is basically just a regular old number. It's a number that doesn't have direction, just has magnitude. So I'm going to take a vector and multiply it by a scalar. Guess what it looks like? It looks like distributing, the distributive property. So here, if I took the vector 2, 3, and I multiplied it by the scalar 2, that means my vector is now at 4, 6. Right? So again, think about graphically what's happened. I took a vector that was at 2, 3. And then when I multiplied it by 2, I am now at 4, 6. What happened to that vector? It became twice as long. Its magnitude grew by 2. Be okay with that graphically? I mean, 4 times a half is 2. 12 times a half is 6. So what happened this time? I took my vector that was at 4, 12, which would be here. And when I multiplied it by a half, I'm now at 2, 6, which would be here. I shrunk that magnitude by a half. All right, the next one's interesting. What happens here with a -2? Any guesses? It's going to reflect it, and the 2 is going to stretch it, right? So if I distribute, that's going to give me -2, -6. And then we can see here graphically, I was at 1, 3, which was here. And now then I'm at -2, -6, which is here. So it's 180 degrees in the other direction, and it's twice as long. Looking here, I'm given two vectors, A and B. I'm going to do scalar multiplication, and then I'm going to do vector addition at the end. So the order of operations still holds. So I have to do the scalar multiplication first, and then do the vector addition second. So let's do this algebraically first before we do it on a graph. So if I did -2 times 1, -5, plus 3 times b, which is 0, -3. This is going to be -2, 10, plus 0, -9. Is everybody okay? What I've done? Distributed those two scalars. And now do your component addition. So -2 plus 0 is -2. 10 plus -9 is 1. So my resultant vector should be at -2, 1. So is everybody okay with what happens graphically here? Right, this one's being stretched by 2 in the opposite direction. This one's being stretched by 3 in the same direction. Right, are we okay with those? So if I just go from here, after I've done that, you can see -2, 10 would be this vector. And then 0, -9. Would be this vector, right? I went down 9 from there. And so then what would be my resultant vector? You can see it is left 2, up 1. The one I have in orange there. Okay, so now we've got two vectors, 5i plus 2j. Which would be here, and 3i minus 4j, which would be here. And it asks me for the angle between them, which means I want to know this angle. So there's a few ways we could find that angle. The way they want me to do it is by using the dot product. So you see here this formula, u dot v equals the magnitude of u times the magnitude of v times cosine of that angle between them. That would be cosine of theta. So in order to use this formula, I need to be able to find 3 of the 4 things. I know I don't know theta. That's what I'm looking for. Could I find the magnitude of v? So if this is v, what would be the magnitude of that vector? 5, right? That's a 3, 4, 5 Pythagorean triple. So the magnitude of v is 5. Could I find the magnitude of u? Yeah, this is not a Pythagorean triple. I'm sure some of you guys are glad, right? Because you're tired of me saying it. This one would be radical 29. You be okay with how I'm coming up with that value? Pythagorean theorem, 5 squared plus 2 squared. The square root of that. Okay, and then can I find the dot product? U dot V. You guys remember how to find dot product? We multiply the x components by each other. We multiply the y components by each other. And then we add those together. So that would be 15 minus 8, which is 7. So the dot product here is 7. Everybody okay? Any confusion? I know it's a lot of different variables in that formula, but hopefully we talked through it well enough. Now let's solve for theta. So first, theta and cosine is being multiplied by 5 radical 29. So divide by 5 radical 29 on both sides. So that those cancel. And so I've got cosine of theta equals 7 over 5 radical 29. And now how could I find theta? I could take an inverse cosine of both sides. And so theta is going to be equal to whatever the inverse cosine of 7 over 5 radical 29 is. And again, I don't know if it wants degrees or radians. It will probably specify. Let's just go with degrees. This seems to be what we've done more of. Questions? Or what did we get? Somebody get this number for me?
74.53.
A person leaves home and walks 4 miles south. So how could I draw that graphically? 4 miles south would mean I went down 4. And then they walk southeast. That's going to be this direction somehow. They walk southeast for 6 miles. How far from home is she, and in what direction must she walk to head directly home? But it's not a right triangle, right? So for me, here's what I think. Because, here's the way I would do this. There's probably several ways. If we watch the video, they'll probably do something different. Because it doesn't give me an angle, I'm going to assume she walked due southeast, which means she was 45 degrees between south and east, right? Right in the middle. So I could resolve this into its components. That's 6. Right? I could find how much did she walk east and how much did she walk south. You follow what I'm doing there? And so because that angle is going to be 45, I'm pretty sure I can make that assumption, then that would be x equals r cosine 45. So in this case, x equals 6 cosine 45. That's going to be 6 radical 2 over 2, which is 3 radical 2. Which means she went right 3 radical 2, and she went down. Is it okay how I know they're both 3 radical 2? Because it's isosceles. It's a 45, 45, 90. So the legs have to be the same. If you didn't know that, you could do this y equals r sine theta. Right, but it's going to be the same thing. Let me finish this one real quick and we'll be done. And so look at the components. How far to the right did she walk? So we're finding this. We're finding the resultant vector. How far to the right did she walk in total? It's given right here. This is the only component that went right. It's 3 radical 2. So she went right 3 radical 2. And then how far south did she go? She went south 4 here. And then she went south another 3 radical 2. Which means that one would be -4 minus 3 radical 2. Right, negative 4 because we went down and then went down another 3 radical 2. So this will be the component vector. And then we could find the angle. When it says what direction does she need to walk, we could find this angle because now we can make a right triangle. Right, you kind of see where we're going. But I know the components. That was the hard part there. And then from there we could find the angle. Like I said, I'll finish this problem. It'll be on YouTube. You can watch it tomorrow if you're here. So now if I take the resultant vector only. So the resultant vector was the one that was in orange. I know it has two components. The x component is 3 radical 2. The y component was negative 4 minus 3 radical 2. Right, for its resultant final portion. And then if the person ends up right here, then you could see if I can find this angle, then this angle and that angle would have to be alternate interior angles. And so I could tell what angle she needs to walk at to return back home. Follow what I'm getting back into like the pirate range. So from this angle, what sides do I know? I know the opposite and the adjacent. So I could find the angle by using, not cosine, opposite and adjacent, tangent, right? Could use tangent. So tangent of the angle I don't know equals the opposite, 3 radical 2, over the adjacent, negative 4 minus 3 radical 2. And now I could get theta by itself by taking an inverse tangent. So theta is going to equal the inverse tangent of 3 radical 2 over negative 4 minus 3 radical 2. Somebody with a calculator help me out. Anybody, somebody? I know you're typing. I'm just giving you a hard time.
Negative 27.235.
Is that in degrees?
I think so. I got that too.
You get that as well? So I'm not going to put the negative. I'm not going to put the negative because I think it's going to mess up with my head. So that's why on my that's okay. So I take the negative out of play, which means this angle here, the blue angle, should be 27.235. So I could say originally they walked 27 degrees east of south. Right? If they walked due south, they would be walking here. But she walked 27 degrees east of south. So to return home, she would need to walk 27 degrees west of north, because this is due north. And you can see this angle touches due north, but it's 27 degrees west of that. Yep.
Just to be sure, tangent's y over x, right?
It is.
And the way you wrote it up there is x over y, not. And I'm just wondering. What? Confirmed. Ty asked me about it, and I was like, I think you're right. And then I said, I'll ask Fitz.
Thank you. Thanks. Yeah, you're right. But I'm still right. And so I'm trying to figure out how to. Normally, if I were to draw this triangle, we normally go on the x-axis first and then the y-axis next to get that hypotenuse. And so if this was the angle where I went x and y, the y value here should be -4 minus 3 radical 2. And the x value would be 3 radical 2. So for this triangle, this should be the opposite y over the adjacent x.
Is that why it's negative?
Yes. That's why it's negative originally.
If you do it the other way, you only get like 1 degree.
So flip it. Put that in your calculator. Do the inverse tangent of -4 minus 3 radical 2 over 3 radical 2.
That's -62.7.
It's what?
-62.764.
So this one's 62.7. Forget the negative. Negative just in the quadrant we're in. Okay? This one's 62.7. What did we find before? 27 point. What was it? Is 0.7 what? 62.4. And this is what? This is 2, 3. It's all in the round. We'll make this 8. That's close to 8. 62.8 plus 27.2 is 90. So from this answer, I'm just going to go 63. This is 63 degrees. It's touching due east. So I'm going south of east. Here, I'm looking at 27 degrees. From here it's 27 degrees east of south. It's the same answer, but a different order. You follow my
Are you saying it's different, like starting points?
I'm saying I drew the triangle differently. It's why we have different. You see how this triangle, like if I took this triangle and moved it over here, I would be finding this portion. If I turn it into a rectangle. And so these two angles together have to add to be 90. So depending on how, like, if it'll let me type in my west of north, or if it's built in, that'll depend on if it'll take my answer or not. Right? But I did it as opposite over adjacent to find this angle instead of y over x, because this is not a central angle, because this triangle does not go to the x-axis. It went to the y-axis. That's why it's not y over x. Way more than we care to even know, okay?
Sorry.
No, I appreciate that. It's like, that never even entered my head that the y over x. Whatever. No.
Like when you're up there at the podium and Tyler, like, I can't tell if he's mad at us or
No, I'm trying to think. I was trying to think, how could I get to? Because I want to plan before I just come up here and wing it, even though I do wing it a lot. But that was a good enough question that I didn't know the answer. A boat needs to head due north, but there's a current flowing from the northwest at 5 kilometers per hour. So this is the same idea as the last one. Because it doesn't tell me how much from the northwest it's coming, I'm going to assume it is 45 degrees, right? That it's exactly in the middle of northwest. So if the current is flowing from the northwest, that means it's coming from this area in this direction. Do we follow that? That used to confuse me the most. When winds are out of the north, that means where I'm at, the wind's blowing south. Right? Because the wind's out of the north. It's not blowing north. It's from out of the north, south. It still makes my head hurt. So because this current is from the northwest, it's sending the water southeast. We follow. Yes, you should be a well-rounded individual, not just math. You should know your directions too, in case you ever need a compass. But it's not like you carry around a compass in your pocket all the time. Oh, you do. On your phone. Okay, anyways. So, this is like I used to tell people they had to learn how to do it in their head because, I mean, you're not going to carry a calculator around in your pocket until you do now. But anyways, that's why we're now changing the way we teach. And now we teach concepts, and now it's harder. You're welcome. Because you got a calculator in your pocket. This vector has a magnitude of 5. Because it's 5 kilometers an hour. All right, so I know eventually I'm going to break this vector into its components. So let's just go ahead and do that right now. So I know this angle is 45. Let me just draw it the other way. That way I don't mess up again in case we have one like Ty. I'm going to draw it this way. Thanks, Ty. No, it's good. So how could I find these components? You could find the x by doing r cosine theta. So here that would be 5 cosine 45. Cosine of 45 is radical 2 over 2, which means this is 5 radical 2 over 2. Everybody's good with that? That's going towards the right. So now going down would be negative 5 radical 2 over 2 because it's isosceles, because it's a 45-degree angle, because we're going exactly southeast. So essentially the boat is going to have to travel in this direction. Right? In some form. I don't know exactly how much, but it's going to have to head this way to fight against the current. Because in the end, I want the boat to go due north. Right? That's where I want it to go. So it's going to have to aim a little bit to the left or a little bit to the west. That way it can go against the current. Okay? So, okay, so the point is, the boat is being pushed off of due north by 5 radical 2 over 2, right? To the east. So I need 5 radical 2 over 2 plus however much this x value is going to be. Right? Think about if I made this purple one a triangle. Right? Again, I'm not great at drawing this because if you've ever seen my actual math work, it's terrible. And I know you guys think it always looks terrible, but it normally looks like this bad. Right? So I've been better. But vectors take me to a dark and scary place. Anyways, I need to know this x value. So how could I find that x value given that the boat can move 50 kilometers an hour? Which means the magnitude of the purple is 50. So, anybody, okay, can anybody tell me what that x value is that I've drawn very strongly over and over again? I didn't do a good job drawing it. I didn't draw it out. Where do we want to end up going? North. So if the water is pushing me 5 radical 2 over 2 to the right, how much should I overcorrect back to the left? Negative 5 radical 2 over 2. Because those have to cancel each other out to be 0. So if this is 5 radical 2 over 2, this x value has to be negative 5 radical 2 over 2. Does that make good sense? So now, thinking about this formula, do I know what the x value is for the purple triangle? Negative 5 radical 2 over 2. Do I know the r value? 50. And I'm looking for theta. Everybody good? So this would be negative 5 radical 2 over 100 equals cosine of theta. Two is already in the denominator, and when I divide it by 50, 2 times 50 is... Okay. Just pretend like I didn't say this. Okay, here we go. Why is theta not by itself? Because I need to divide by 50. So if I divide by 50 on the right, I have to divide by 50 on the left. But that would be a fraction over a fraction. So instead of dividing by 50, I could multiply by the reciprocal, which is 1 over 50. Are we okay? This is why you guys need to speak up when Trey and Ethan aren't here. Okay. Or even when they are here, I guess I should say. Because I would have just kept rolling like nothing. Because they keep going, yeah, and y'all wouldn't say anything. And so I just assume everybody can get it to 100. You see where I got the 100 from now?
But that's why the number sometimes multiplied in the numerator instead of the denominator.
That's why I get so confused and I write it like I'm a 5th grader every single time. Multiply by the reciprocal. I just do it every time.
My math knowledge is like Swiss cheese, so that's why.
You got these holes all in your...
Pretty much elementary math. I just forget the most random details and they'll come back to bite me.
Inverse cosine of both sides. Has anybody done that for me yet? The inverse cosine of negative 5 radical 2 over 100 to find theta. 94.50. 94.50. Like this? 055? 94.055? Which means I've rotated in total 94.055. Thank you. So if, all right, this one's already set up for me. I've got to go west from north. So I need to know, because this is due north, then how much am I going west? So what is this angle? That's correct, because the 90 tells where I rotated from my original. Here. You can't say this? Look at this. This is as clear as can be. This is physics if I've ever seen it. 2 ropes hold a crate as shown below. The tension in one of them is 820 newtons in a direction of 35 degrees with the horizontal. The other has a tension of 934 newtons at a direction of 44 degrees with the horizontal. So how much does the crate weigh? So that's the total tension on the ropes that's also due with the being pulled sideways, right? That's why this is total tension. What I really need to know is how much is this rope being pulled down and how much is this rope being pulled down? Because if I can sum the newtons that are being pulled down in both of these directions, it's going to be equal to the amount of newtons that are being pulled down by this block, because they're having to counteract it in the opposite direction. All right? This is a physics problem. If you like this kind of stuff, take a physics class. It's so much fun. Okay, so does anybody see anything that might be helpful for us here? I see right angles. Okay. Very good. I do too. I can find this angle. What is it? Why? I can find this angle. Why? Is everybody okay with that? Alternate interior angles. And so I'm really looking for the y's this time. So I need to find this y value and this y value. So I'm just going to name them y1 and y2. That way it'll be easy for me to tell the difference. So let's start with y1. How could I find the magnitude that y1 is pulling down? Oh, gosh. No, not the law of signs. Oh my gosh, no, don't do the law of signs. Y equals R sine theta. Do I know what R is? Do I know what theta is? Opposite and hypotenuse. Right? Opposite over hypotenuse. Never say law of signs ever again. It's done. Look at Y2. How could I find Y2? R sine theta. Next time, just speak up. Instead of making me listen for whispers. I'm getting older. I used to could do that fine, but it's getting harder. All right? I mean, oh my gosh. The arrows represented as a vector quantity. You talking about my box down there? Because of physics. Again, you haven't had it before. So this box is pulling down its weight in newtons because this rope is having to counteract it and pull up the opposite weight. Because if they didn't pull in opposite directions, then this would sink. Okay? So that's where it reaches its breaking point. If it can't match the tension being pulled down, or the newtons being pulled down, then the tension in the rope would break it. Too much to explain because we don't have a real physics class. This is just trick. Gravity pulls the box down, but the rope has to pull the box up. Otherwise, gravity would win. So they have to be in opposite but equal forces.
That's too much. We can just keep going.
Like, yeah. Never mind. So like right now the earth is pulling down on me. Like we don't talk about our mass or our weights in newtons. We talk about it in pounds. Right? But it's the same idea. The earth is pulling down on me at 250 pounds. Because that's what I weigh. But then I'm having to exert a force on the earth in the opposite direction. So my legs are exerting 250 pounds of force in the opposite direction to hold me up. Because if it didn't, then the gravity would be winning. I wouldn't be exerting that force.
Is that from the space?
No, nothing to do with space. Okay, so, oh my gosh, what did we get? Did we get these numbers? What are they?
470.333 for Y1 and 648.811.
And so to find the total amount that the crate weighs, we add those. Y1 plus Y2. And hopefully we get this number. We're going to be close. Is that what it is?
That's all you gotta do?
Yeah. So ran out of time. There's two more examples that I'm just going to let Mr. Niblet show you those because I'm not going to have time to finish one of them. You can see I'll go ahead and mention this. In the next one, you have a formula for work. Work equals force times displacement. So let me write that out. Work equals force times displacement. Force is what we've been working with. That's how much the vector's pulling, its magnitude. Displacement is how far it was moved. So you can see, reading the next one, you're pushing a box, or a force of 30 pounds is exerted on a table to make the table move. So you're going to find its displacement is 12. You got to find the force. And then once you find the force, you can find the work. Anyway, sorry to Trey and Ethan. I didn't get finished. Watch Mr. Niblett. And Pedro. Pedro will probably watch this too. Reagan, I know you're never watching this. Cole, you might watch. I don't know. You're in between. I'm having a hard time telling.